was mistaken yesterday when I said we were done. Here we go with number 41. So, starting with 41, they want us to solve this system graphically. So what you want to do is you want to put them both in y equals form, and then you can either use your calculator to find where they intersect, or you can draw it out on paper. The first one becomes y equals, it'd be negative 2x plus 13 if I put it in slope-intercept form, because I'd move this to the right-hand side. So that's kind of hard to graph on here, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it'd be 11, 12, 13 would be my y-intercept. Start up here and go down 2 and over 1, which would put it at 111, and then go down 2 and over 1, because the slope is negative 2. So that puts it at 2, 9, then down 2 and over 1, down 2 and over 1, and I would just draw this line as best as I can. And it's really hard to do on this slate, but on your calculator it'd be a little bit easier to do. Alright, and then the bottom one, if you solved it for y, you'd move the 2x over, plus 1, and divide by negative 3, so that'd be 2/3 x minus 1/3. So you'd start at negative 1/3, go up 2 and over 3, and then up 2 and over 3, cross somewhere in there, which is really hard for me to tell on here. So let me get the calculator and see if we can figure out where they're actually crossing. Alright, I came over here to calculator and typed in the two equations. It's negative 2x plus 13 and 2/3 x minus 1/3, putting parentheses around the fractions. So then if I graph those two equations, they should intersect, and it should be over here like we were looking at. We just need to figure out where that point is. The blue line is our first line, the red line is the second, and then to find out where they are intersecting, we go to second, trace 5, and then enter is on the first curve, and then enter, and it says guess. So enter one more time, and there's our intersection point, 5, 3. So my answer to that question would be 5, 3. Alright, next question. Problem 42. They want us to solve this, I think, by substitution. So the easiest way to do that is to solve for x or y and plug that into the other equation. So I'm going to take this bottom one and I'm going to add y. So it becomes x equals 5 plus y. What I'm going to do is I'm going to take 5 plus y and plug it in where x was. Now, if you'd prefer to use another method, that is perfectly fine. But if you use substitution, the top line becomes 5 plus y. That's where x was. And then plus y equals negative 7. So it was x plus y equals negative 7. So since x is 5 plus y, I just replaced it. So that becomes 5 plus 2y equals negative 7. Subtract 5, you get 2y equals negative 12. Y equals negative 6. And if y is negative 6, that's half my answer. We'll plug it in here. X equals 5 plus y, which is negative 6. So x equals negative 1. My point would be negative 1, negative 6. Make sure it checks out in both of your answers, and it does. Negative 1 plus negative 6 is negative 7, and negative 1 minus negative 6 is 5. Okay, the next question wants us to use elimination. So what we have to do is we have to take these two equations and we want them to find one of the variables that cancel. So we could either cancel the x's or the y's. I'm going to cancel the x's, and 7 and 5 both go into 35. So we'll do the top line times 5 and the bottom line times 7, and then one will be a positive and one will be a negative. So the top line becomes 35x minus 5 times 7 will be 35y equals 112 times 5 is 560. And the bottom line, if you multiply times 7, would be negative 35x. So you see these x's are going to cancel. And then that'd be minus 28y, because 7 times 4 is 28. And 17 times 7, negative 17 times 7 would be negative 119. Add these two lines together, the x's cancel. I get negative 63y equals 441. Divide by negative 63. Y is negative 7. So now I know half my answer. If y is negative 7, plug into either one of these. I'll do the top one. So 7y minus 7 times negative 7 equals 112. So 7y equals, that becomes plus 49 equals 112. Subtract 49. You get 7y equals 63. Divide by 7. y is equal to, oops, this shouldn't be y, this should be x. 7x. 7x. X is equal to 63 divided by 7 is 9. X is equal to 9. Sorry about that. It should have been 7x at the beginning. 7x minus 7 times negative 7 equals 112. So x is 9, y is negative 7. Alright, one more right quick. Line these up. The problem with these two problems is that they're not written, that everything's not lining up. So I'm going to redo that. I'm having trouble with x and y right now. It becomes 8x. I'm going to move this over here. 8x plus 4y equals, I'm going to move the 36 to the other side, negative 36. And then negative 5x minus 2y equals 20. Now everything lines up. The x's, the y's, the constants. I multiply this bottom line by 2. That'll take care of the y's canceling. So the top line stays the same. Bottom line becomes negative 10x minus 4y equals 40. Add these two lines together, you get negative 2x, the y's cancel, equals 4. Divide by negative 2, you get x is negative 2. Plug that into one of your first equations. Whoops, x is negative 2, so I'm going to do 8 times negative 2 plus 4y equals negative 36. That's negative 16 plus 4y equals negative 36. Add 16, you get 4y equals negative 20. Divide by 4, y is equal to negative 5. So that's my answer, negative 2, negative 5. Number 45 is also, these are at equilibrium points, so since they're both equal to y, you can really set them equal to each other and just solve it. So add 60x to both sides. So divide by 180, divide by 180, 3600 divided by 180 is x would equal 20. And if x is 20, y equals 120 times x. So 120 times 20 is y equals 2400. So at 20 is our quantity, we would have $2,400. So that'd be our price. This will be our number. All right, we're going to pause there, and I'll pick up with the next video.